Okay, Assalamualaikum warahmatullahi taala wabarakatuh. Okay, ladies and gentlemen, thank you very much for attending the webinar today. You have seen the videos from MPC. So this webinar is hosted by MPC. MPC is Malaysia Productivity Council. It's an agency under MEPN, which focuses on improving the productivity of companies, especially SMEs. Okay, my name is Muhammad Shazlan bin Muhammad Anwar. I am the chairman of subcommittee of the Industry 4 and Smart Manufacturing Subcommittee under Samantha Central. So Samantha and MPC has been collaborating with MPC to further develop and improve the productivity of our SMEs. Okay, particularly we are focusing on the machinery and equipment productivity nexus. Okay, so this is the first seminar in this, okay, for this year. So the focus for this year is actually to boost productivity with emerging technology in manufacturing industry. In particular, we are focusing on what we call PLM, okay, product lifecycle management. Okay, to give you a brief overview why this topic is chosen and why this topic is very crucial for improving productivity of companies, especially in manufacturing. Okay, because effective product lifecycle management brings together the many stakeholders, the departments, employees, that are involved with the product's production to streamline their activities. Okay, with the ultimate goal of producing a product that outperforms its competitors, highly profitable, and of course sustainable. Well, this is as long as the consumer demands and the technology permits lah. Okay, PLM, or short for Product Lifecycle Management, help organizations cope with the increasing complexity and engineering challenges of developing new products. Okay, they can be considered one of the 4 pillars of managing the corporate information and technology of a manufacturing company. Okay, the other 3 is, you have heard of CRM, customer relationship management, supply chain management, and of course ERP. So with us today, we have 2 specialists in this topic. First, we have Mr. William Goh. Okay, he is the technical head for engineering solutions of Hitachi Sunway. Okay, William has more than 8 years of experience in engineering digital solution industries. Okay, by providing CAD, CAM, CAE solutions to engineering organizations throughout the Asian region. Okay, he has presented himself as a trusted partner by implementing solutions towards customer challenges in a consultative and constructive manner. In recent years, William has begun to shift his focus on being a specialist consultant towards engineering organization. So he is one of the best person to elaborate this topic on Siemens, on PLM. Sorry, not Siemens. Okay. The second person is Ms. Nicole Chiang, the manager of business division for Mitsubishi HC Capital Malaysia. Her focus and strength is on equipment financing. She has at least 10 years of experiences in dealing with financing all these equipment. Well, of course, after we have heard of the what PLM is all about, why we need that. So the next thing to talk about is how can we have that system. So this is where Ms. Nicole Chiang comes in. Okay. Without further ado, I would like to let's start the webinar. Okay, and I'll pass the floor to Mr. William.
All right, thank you, Aslan. So just give me one moment to flash out. So let me know when you can. So let me know when you can see my screen.
Yep. So now.
Right. Right. So I'm William. So I'm the technical head for engineering solutions. So I'd like to thank MEPN for inviting me to talk about today's topics of PLM and the futures of next generation design in manufacturing. So just a quick run through on the topic we're going to cover today, but I'll only have 30 minutes. So I might not be able to talk about the closed loop digital twins, but anyway, so this is roughly the agendas. So I'll just give you an introduction to what is PLM. So what is the product lifecycle management, and then let me talk about some topics about digital twins and how your next generation design should look like and how your next generation manufacturing should look like. Then we try to close things with the closed loop digital twins in terms of simulating your production floor and how you can improve productivities in summaries. So what is a PLM? So if you have no idea what is PLM, or if you have very minimum information about PLM, so it actually started from product data management, which is PDM. So product lifecycle management is the full solutions, which is meant for enterprise, but it started with PDM. Now, it goes back a little bit on the early 80s. So it really started with a CAD drawing. Old timers, maybe you started with AutoCAD or MicroStations. Then eventually, 3D comes into the pictures. Brands like Autodesk, SolidWorks, Solid Edge, NX come into the pictures, where you can draw parts faster, you can do design changes faster in these systems. Now, as your designs grow, as complexities comes in, so your drawings always comes with revisions. So design is always about changes. So there's no one design that will say, I first time designed it and it's correct from the beginning. So it's always about the changes. So it's either in change in design, change in material, change in dimensions, and these involve a lot of documentation. It involves a lot of changes and revisions of data, and then a PDM was introduced to manage these changes so that people can focus on their design rather than focusing on searching for files, managing these design changes, getting the right revisions out to the manufacturers on the production floor. Now, in today's context, PLMs defined as the process of managing a product life cycles from concept through designs and manufacturing to sales services, and ultimately comes into a retirement. Let's talk about a phone or a PC or anything. So every single year we hear new models coming out and so forth. That actually part of the PLM. Now, a typical phase of a product development looks like this. It started with the concepts and design. It goes through the developments and the iterations, and then it passed through the productions and launchings where the prototypes are being built up. And then it goes into the stages where support and services come into the pictures, and then eventually it goes into product retirement. Now, if you are involved in any parts of these, so meaning that you directly or indirectly are already part of the PLM. Right. So, so if you put it into stages, what you can see over here is that now you started with CAD drawings, then you already using a 3D CAD modeling, and then you have a PDMs to manage your revisions. So as your organizations grow, you go into the PLM stage. That will be for the enterprise, where all the documentation changes, QC are all being managed. So that is like what Jaslan has mentioned, the one pillars of the organizations, which is the PLM. Now, that's the quick introductions of what a PLM is all about. So I hope that gives you some ideas of where you are in your organizations or your organizations in a PLM adoptions. All right. So now, how a PLM of the futures looks like. So it actually comes with the comprehensive digital twins. So the digital twins comes in terms either from the product design perspective or even on the productions like a factories or plant life cycles. It's all comes in together. So if you have a digital twins, so you can reduce a lot of errors and eventually improve your productivities in your daily operations. Now, as my topic, so going deep dive into the topics, so we talk about the next generations of design. I use NX as examples because Siemens NX is a very comprehensive solutions where it offers a comprehensive digital twins in terms of your for your designing or for modeling. So the main focus here is to increase the 3D data reuse, and then it concentrated on the industrial-based workflows because newcomers in the industries might not understand the industry well. So you need the design tools that comes with all sort of industrial knowledge that can identify the errors before you go into the productions. So, and of course, since there are so many native CAD software or so many native modeling software design tools out there, you want something that have the capability to edit the models, do design changes easily without needing you to, select the one specific tools to do the designs, but rather one tool that can fit everything. So let's look into some key capabilities of how a next generation design should look like. So let's look into these particular examples of surfacing. So if you are in industries that requires a lot of styling of surfacing, so industrial designing, designing your products. So these are one approach. People name it as sub-modeling, and like in NX we call it as a real life shapes. So it started with a basics models, or even started with importing an image, and then from there we split the models into cages and different domains. Then from there, drag and tools, okay, to style the surface at ease. By controlling the triad, by controlling the arrows, doing rotating into the models to get the best shapes out of, or to capture your design intent in creating the models. Now, to further editing is actually quite simple. There are different tools that helps you to open one of the areas. Okay, flattening the base of the geometries, which give you the shapes or to capture the intents that you want. So to skip a little bit, so to the end result. So you will see that with further capturings of the edges, okay, giving out rounded tools, removing all the sharp edges, okay, so that it gives you the best models or the best shapes that you need here. So further detailings, and you got your models right, okay, which is further for the FMEAs or further for creating the claddings or the structures from these particular industrial design models. Now, to look further in, you might already heard about these ideas called generative designs, so or topology optimizations. So to do that is actually something about design explorations of spaces. So the workflows are rather simple. We define all the areas which is important, like joints areas, like areas where you cannot remove away. Typically, both the nuts areas, screw areas, joints areas. So in this case, the gray color solids is where the areas you cannot remove away because that defines the joint between different components. Now, particularly some define some load cases and define some rules, like for example, the minimum thickness, the weight of the parts. So which one is a priority, whether you are focusing more on the strength or you are focusing more on the weight, or you want to design a lightweight product, then define those rules and then let the digital solutions or let the software run the studies for you, and it will give you a very futuristic the models which defines the structures that the minimum structures or the design explorations space structures that give you the results while fulfilling all your design needs or capturing all the design intents. Now that is a generative design. Now, since we're talking about generative designs, we might also want to look into data like scan data or etc. So, usually these data comes in a format we usually call OBJ, .stl files. if you have a 3D printers with you, have a 3D scanner with you, you will be point clouds, meshes, data, etc. Now, often when you need to do editing, so you might require different tools, do the conversion into solid before you can do further editing. Now, a technology is called convergence modeling in NX give you the flexibilities and the capabilities to directly edit these STLs data. So in this case, when you notice the bridges are not up to standards or it's too thin, so doing some simple offset is possible right from the interface itself or right from the capability itself. So in this case, we are going to do some offsets on these models to make it thicker so that it can include the strength of the models. So, so after all the let's see. So as you can see from here, we are able to do some offsets so that it becomes thicker. So after all the detailing, so if we are noticing there are some unwanted features, we can also do very quickly removing of surfaces of the STL directly and fill up the holes so that your models are ready to go and ready to be put in back into your assemblies, for further validations or eventually fabrications. In this case, this will be a 3D printed parts, right? So that is a convergence modeling technologies where you can directly edit things on the STL or OBJ files. Now, next, in terms of maintenance or in terms of validating your designs, so AR or VR technologies are very common now. So in the NX, they are a one-click solutions where you just click on the VR connections and you will be able to go into the with the right infrastructure, of course, with VR headsets. So you are able to go into the virtual reality environment to do the checking on the models, everything that you do in your CAD designs, you are able to do it over here. Like for example, we are able to do some section views over here, doing some measurement, checking the geometry, whether it is as per design standards, etc. So furthermore, we can also do some reworks. If you want to do some remarks on the reworks or check on the form, we are also able to do that as well. So putting in comments as simple as putting in selecting on geometries or selecting or filling up on the models, putting in some comments and then snap the pictures, and that will be recorded in the systems for any reworks or communications with the production floor or the designer. Now that is part of the digital twins to improve your productivity without needing you to actually build that models. Now, that is one technology that is used for maintenance or validations of models. Next is like what I mentioned earlier on the tools that is able to do design changes directly, regardless of what kind of native software or what kind of native geometrical creation tools that you use. Now, in this case, we are going to do some changes on the brackets. So you will notice that these are not the traditional parametric modeling where you need to define dimension and so forth. So changing the models directly are easy by just dragging and drop on surfaces or even define the snapping of the surfaces edges to a point. So to raise the difficulties a little bit, we look into the more complicated geometries over here, which is a bracket like this. So to change these slots might involve a lot of work, but with synchronous technologies or with direct modeling ability, you are able to resize it or select the whole host and do a moving. It can be done easily. Now to go one step higher, right? So a typical complicated geometry like this, we are able to do designing jobs changes very easily. Again, the workflows are the same where you select the faces and do the changes by drag and drop on the geometries, and then add in additional selections of geometries to indicate the changes, if required, are possible as well. So in this case, by selecting the two geometries, you are able to do the changes. Now to look at the, just keep a little bit on these portions. So in this case, we are trying to reduce the size of the radius on this complicated geometry. Like you can see, by defining the parameters, the radius are reduced straight away by after the loadings. Now, to show further complexities, we would like to move this whole fan vent to a new locations. Now, the workflows is the same. By using a selections tool, we select these particular areas of geometries and move entirely to a new positioning. Now, which is in the typical scenarios, you might require the native CAD to do all the parametric changes, etc. But with synchronous technologies, what you can do over here is by selecting the geometries or the solids that you want to move, and then the next thing is just moving it into the locations and wait for it to load, snapping it into locations, or just push or just moving it with a triad and wait for it to load, and everything will be moved entirely, and your models updated accordingly. Now that is synchronous technologies where you are able to do editings on geometries regardless of what kind of native software or native CAD geometry creations tools that you have. That is on synchronous technologies. And of course, in NX, we have more robust and comprehensive capabilities. So to address the next generation of design, so want something that is able to do things fast without reliance on the native capabilities of the software or etc. Now, to bring one step further, of course, in the digital twins, of course, we can look into simulation, CAE or CFD kinds of things. So we have mentioned a little bit about topology optimizations on the designer level. There are also topology optimizations on the analyst level. So there are structural, thermal, motions, vibrations, and even advanced physics capabilities like vibrations, acoustics, multi-physics are all possible in the next generations of design as well. So just to do a recap. So in the design portions, we would like to promote the data reuse of design. We want to concentrate on tools that can that is defined by industrial-based workflows like sheet metals, structures, designing tools faster, editing tools faster, and then of course there's a synchronous technologies which are shown lastly, where you can do editing of models very fast. Now, if you look into, of course, you have a design parts, then definitely we have a manufacturing parts as well. So manufacturing, there are all sort of manufacturers out there. So today I am focusing on the CAM portion, which is the CNC machining parts of things. So we are talking about a digital machine shops or digital part production and how a digital part production should look like. Now, in the digital part productions, it comes from these different aspects and these different domains. So it starts from a part preparations, in terms of modifying the parts. Then it comes with the tools and fixture design. Then there are CAM programming. So some customers or some organizations, they look into the CMM programming. So there's a process planning as well to plan the process. So most organizations now are still using it very manual, either in Excel or PowerPoint. And then there are tools, libraries where you can keep all the tools, whether it's a soft tool, hard tools, or a CNC machining tools. And then so this is on the planning parts of things, and then this is on the production parts of things, where we look into shop floor connectivities, where you can send your NC programs straight away to the production floor. So shop floor program validations and machine simulations, where you can see the movement of the kinematics, so that you can avoid any possible tools where tools collisions with the workpiece or tool collision with the machines before even you send over to the machines for CNC cuttings. Now, of course, then there is a CNC cuttings, shop floor data, tool management on the production floor, and also CNC inspections, executions, with validations before sending over to the CMM, sorry, CMM inspections. Now, to go dive into it, so we look at it, we look at it from a scenario perspective where how an integrated process steps should look like. So it started from a CNC programming on, and then it goes into production scheduling, and then send over to the CNC machinings, and then the product executions where you want to do some monitoring on the performance of the CNC, and eventually a quality inspections platforms where you can do some QC on the parts, recordings, what are the possible solutions, the preventive measurements, or even maintenance measurements over here. Now, so I'm not talking about all the steps over here, all the process over here, but I'm just narrowing down to look into some of it. So in the CAM programming portions, NX CAMs provides a wide range of functionalities. So from high-speed machining methods to 2.5 axis to 5 axis. So all these are part of the solutions. In the next generations, you actually need to look into a more highly capable CAM programming CAM programming to assist you in the machining processes rather than manually or something that or some tools that require you to do a lot of works. Now, a showcase to use on some advanced capabilities over here, which is the advanced milling. So in the NX, we have the capabilities to do editings on the models accordingly. So these are also part of the synchronous technologies that I mentioned earlier, where selecting the geometry and removing it. So in this case, we're removing some of the curvatures, some of the faces, so that which do not require, which is not part of the machining. So hand programming allow you to do some viewings on the tool path simulations, so that we get an ideas on how the tool movement, which is if you are a CNC programmer, you will be appreciating that, because that will decide the surface finishing on that part. So if you are talking about mold and dies, the surface finishings will be a very decisive criteria of quality. So capabilities like these, which is cutting on the surfaces with a guided curve, will also help to give you a good qualities of finishings accordingly. Now, to go one step further is the of course the shop floor documents like NC programming, the tool setup document. So all these are capable and automated from a system. And then there are the machine simulations where you can validate the movement, the kinematic movement of the CNC programs, even before you sending over to the machines. So these will help you to reduce a lot of errors or to validate it, especially for their new workflows come into the organization. So they might not familiar with the machine. So this will help them to understand and validate all the machine capability of kinematics before sending over to the machine. We'll skip on this a little bit on the wire EDM. So that is on the wire EDM capability, and that's basically we have concluded on the CAM programming. Now let's look into the CNC machining parts of things. Now, and ideas over here is how do we increase the throughputs? So it can be as simple as understanding whether your machine are running or not, to a detail like, for example, how much spindle speed, how much loading your cutting tools are having now. So whether it has exceeded the limits or still within the limits. So the overall diagrams that shows this is actually there is each computers, or there is devices that collect these data from the machine controllers and then send it to IoT platforms or cloud platforms for the analysis and then feedbacks accordingly. So, and to give you an idea is on these is in these cases. So we are trying to identify. So is there any surge in the loads? Okay, which will potentially potentially increase the chances of machine require maintenance, or there's a potentials of the parts being uh, doesn't meet the qualities because of the sudden surge in the load, which will cause some areas to have some lines on the finishings. So in this case, well, you are seeing that we are seeing that throughout the whole machining, there are some areas we have which is exceeded, or there are certain jerks of the top in terms when the spindle speeds and so forth. So these are a monitoring tools. So like I mentioned, it can be as simple as understanding whether the machines are running, or go up to the extent of knowing the actual spindle speeds or data or the tops on the loads on the cutting tool. That is on the CNC machining portions. Now, going into a quality inspections validations. So what we are seeing here is platforms that help you to guide through the process, digitalize your process of QC inspection. So we have an overview that captures the parts details, the information where QC required, critical area where QC requires. So who are the team members that involved, and defining the problems of the whether it's within tolerance, whether the finishings are not good, and then what kind of contaminant actions requires, especially in the aerospace or the automotive industry. And then there are root cause analysis, which is built into the platforms to allow you to go through the Ishikawa's methods on identifying what is the root cause, going through the process to identify the root cause of the problem by asking 5 why, right? So, and of course, you can also define the corrective actions and the preventive actions required from these particular QC actions, and then to generate and eventually to generate reports, okay, in a built-in report generations where you can just export this out without needing you to go through the whole Excel or Microsoft Word process of generating the reports again. So that is the platform to define the quality inspections validations. Now, a good digital twins of the manufacturing floors should have an integrated process going through from CAM programming to the end of the quality inspections validations. So traditional workshops actually look something like this. So where you have a design data, then you have a picture designing, then you have these resource management where you need to do, or you need to collect all your tools data and put in, maybe you save in a server, maybe you save into a silo PC, and then eventually send over to the CNC controller machining through, and then you have these all sort of quality documents to fill up, right? So a modern machine shops will look something like this, where things are more organized, where designs, okay, passing through the data to a process planning, quality plan, then passing through a CAM programming, NC programming capabilities or NC programming systems, generating the NC codes, sending to the machines to run the to have all the setup sheets, and then all the operation SOP, and then eventually you can monitor your machines or do the machine simulations to make sure that everything's are fine. Now that actually is a part of PLM. Whatever I'm showing over here is actually a part of PLM. Now, of course, you don't need to be afraid. Wow, there are a lot of things that I have over here that I need to implement. Actually, no. Okay, so don't have the misconceptions here, is because I think only enterprise, a big enterprise, have the time, the budgets to do all these sort of things. So what are my intentions over here is to share you an ideas of how a digital twins can look like in design or in your manufacturing, and hopefully you can get some inspirations on what kind of improvement you can get out of your daily processes. Like I mentioned, it can be as simple as, do I even have a CAD system over here? Do I even have a data management system to check on my designs, really manage the. Am I spending a lot of time in searching for the data and making sure that this is the right revision before I send to the customer or send to the customer or send to the production? If I have a machine on the floor, do I even know that these machines are running? Do I need to go down to the production floor to ask this guy, hey, is the machine running? What parts are you running now? So, or you prefer to have, or you want to do an improvement where you have a dashboard, or even from your mobile devices, you are able to know, hey, I have 10 machines, 5 are running, which part they are running, and able to have the visibility. So things as simple as these are possible on your end. So it doesn't mean that you need to have a full flag of PLM in the pictures. So just to go into the last topic a little bit, is the closed loop digital twins. So a closed loop digital twins are you can call it as a plant simulations, where if you have a production floor and you want to know the total throughputs. So a good examples are fulfillment and distribution centers, which is you can treat it like an Amazon, DHL, or even airports, where they're handling a lot of parcels in a day. So to understand that further, let's try to understand one thing over here, which is a discrete event simulation. So what does a discrete event simulations looks like is that there is the input. So then they go through different processes. So, and then eventually there is the output. So what you are seeing over here is actually where the first part is the unfinished part, where the parts are loaded in. Then second, station 1, station 2, station 3. You can treat it like a furniture assembles house, where first you cut the raw material into pieces. Second, you do some further processing, and then lastly there's assembly, and eventually it goes to a finished part where it goes to the shipping. So from here, we are able to simulate, months or even hours of productions that in just a few seconds or a few minutes. From there, you are able to identify what is the total throughput of these particular simple discrete events. So, and you can see over here is that after 8 hours, what are the total parts that we have, and each stations, how much time are they spending on average to process that particular production. So from here, you can decide that whether you require additional stations to process that part so that there are no bottlenecks in the middle. Now, of course, to bring to another levels of a plant simulations is what you see over here is a total fulfillment centers, where you have receiving, receptions, unpacking, loading, pickings, shipping, and dispatchments, all sort of processes over here. Now, if you go deep dive into each areas of it, when you start the simulations, you are seeing the boards are starting to bring in the parts to different areas for processing. So from here, our objective is that is the truck intervals are good enough? Do we have enough operators of these stations? Are the stations are processing parts well? Is there any bottlenecks over here? Is there any things online which is causing total reduction, etc. Now, if you have the fast-moving production floor, so these can be a good simulations that is good for you to understand the throughputs and even do an experimentals and optimizations over here. So, or else you might require to build out your stations, run the studies for, run the actual productions for maybe months or hours. In this case, these things can easily finish within 4 to 5 minutes. All right, after the productions, and yeah. So just to do a summaries of a PLM portfolios. So if you look at these, earlier we defined what PLM is all about. PLM is the product life cycle management, which is from the product planning, from conceptual designing up until the product retirements. So actually a lot of things involved over here, which might be a little bit mixing on the ERP and the CRM. But PLM are very engineering focused and manufacturing focused, where we can look into the program management, the project management, and eventually go into the product design, process planning, validations, production engineering, production executions, and eventually reporting on the tracking, which I have presented earlier. So, which that is what Hitachi-san Way's PLM portfolios are focusing on, which is project management, product designing, process planning, improving on these very engineering organizations or engineering process related tasks is our forte in helping an organization improve their productivity. And that I exceeded a little bit on my time. That is what PLM is, and I hope that it gives you some inspirations on which part in which process in your organizations that you can improve, and let you think that what kind of improvement that you can apply on. Even a very simple improvement like digitize something into maybe a Google Drive, can help to increase the visibilities of your production floor, of all your engineering design. And with that, I pass it back to Encik Saslan. Thank you for your time.
Thank you very much, Mr. Goh. It is very impressive. It is very mind-blowing. I never thought that the simulation technology has actually grown so much that you can actually simulate from the design stage up until production, up until where the product goes out from the warehouse. Wow, there's a lot of information here. You managed to compress it in half an hour. I'm like, wow.
Yeah, there are a lot of information. So I hope that it gives you some inspirations of how a PLM should look like. Right?
Yeah, I have a bunch of questions, but before that, let us pass the floor to Miss Chiang first, for her to explain all this interesting technology, right? And people are getting interested on how can they have a taste of the tech. So maybe Mr. Koh Chang can start sharing. Passing the floor to Mr. Chang.
你有看到我的 Hello, afternoon, everyone.
Good afternoon.
Is everyone can see my slides?
Yes.
Okay, that's good. Okay, so let me introduce myself. I'm Nicole Chiang. I represent Mitsubishi HC Capital Malaysia, and my colleague Hao Junjie also joining in this presentation. Okay, so yeah, Mitsubishi HC Capital Malaysia is actually more focused on asset-based financing. Okay, so previously we are known as Hitachi Capital Malaysia and Berhad. Okay, so let me introduce about our company profile. Our company actually have one HQ in KL and 3 branches in Malaysia, which is located in Penang, JB, and KK. Then our managing director is Mr. Lee, and our deputy managing director is Mr. Tano-san. We are actually 100% owned by Mitsubishi HC Capital Asia Pacific Private Limited, and currently we have about 100 staff at the moment. So let's talk about asset-based financing. So many people will ask, what is asset-based financing? So asset-based financing actually is lending or funding secured by collateral. So what's the collateral that I mentioned? This is actually like machineries and vehicles. So we are actually focused on hire purchase and leasing for asset-based financing. So hire purchase and leasing actually is the most common methods to finance the purchasing of equipments. Yeah, so in this hire purchase or leasing arrangement, the customer don't need to pay a huge lump sum of payment, and Mitsubishi HC Capital will make the payment on behalf and disperse the loan to our machine vendors. Okay. So the equipment that we finance are actually movable or non-movable assets, like vehicle, factory, machineries, and etc. So the tenure that we finance is actually 18 months up to 60 months. So 1.5 years up to 5 years. So the maximum financing is 5 years. Okay. So the minimum loan amount that we actually offer is 100,000. And be able to finance the margin of finance up to 100% of the machine cost. So yeah, upon getting this financing with Mitsubishi HC Capital, the customer must get the insurance, which is normally financed by us, yeah, or get from us. So you can see, if let's say the customer is getting a loan from Mitsubishi HC Capital, and we have approved the loan, then the client have to sign the leasing or HP agreement with us. Then subsequently, we will issue a letter of undertaking to our supplier. For this leasing arrangement, for this hire purchase agreement arrangement, the customer will issue the PO to suppliers, and the suppliers will deliver the equipment to the clients. And yeah, at the end, then we will make the payment to the supplier, and customer subsequently will make the installment based on the fixed installment that we actually propose. So the equipment that we finance are actually like industrial machineries, trucks, forklifts, warehouse facilities, racking systems, IT system, security system, solar panel, and also these are medical equipments. So the benefit of hire purchase and leasing is actually to ease the cash flow management of the clients, because the customer can actually using their current cash flow for other purpose instead of they buying the equipment in lump sum. So subsequently, they also actually can be predict on their interest cost on the equipment, because the interest that we charge is actually on the fixed interest. Likewise, like those term loan or housing loan, they are actually based on the OPR. So the changes of interest rate might affect the customer, the cash flow in the future. So ours is a fixed interest rate. So of course, we have a flexible terms and condition, because we can finance up to 100%. So the customer don't need to get any money from their pocket to buy an equipment. Then subsequently is actually on the tax purpose, the customer may have this capital allowance under this hire purchase arrangement, so that they can have a cost saving on the tax. So let me give you an example on how the calculation of this hire purchase or leasing. Okay, for example, the equipment cost is 100,000. And the down payment is 0, means we are actually financed 100%. So the tenor is 3 years. And okay, on this equipment financing, we are collecting actually prepaid and advance installment 1 + 2. Okay, so normally this is a must from the customer. Then this type of contract in such an arrangement is industrial hire purchase. So the interest rate that we charge, for example, is a 3.8% per annum. So based on this calculation, the monthly installment is fixed at 3,095 per month for 3 years. Okay. So under this hire purchase and leasing, okay, of course, there's a difference on hire purchase and leasing, but it's actually more to accounting purpose and tax purpose. So it depends on the client, how they want to make a choice on whether they want to get this hire purchase or leasing. Is up to their accounting system, whether they want to choose hire purchase or leasing. Okay. So in our collaborations with Hitachi Sunway Information System, we actually give a special arrangement for Hitachi Sunway. Okay, our normally loan amount finance is 100,000, but due to our collaboration with Hitachi Sunway, our minimum loan amount is 50,000 only. Okay, so we also can finance up to 100%, and the tenor is actually from 18 months up to 36 months, okay? And the interest rate is ranges from 3.2% to 4%. Of course, this interest rate is actually based on the tenor that actually require from the customer. So some of customer might prefer shorter tenor, then the interest rate will be cheaper, okay? So of course, we will actually collect this advance installment and prepayment from the customer, which is 1+2. So a lot of people will actually ask, what is this 1+2 for? So 1+2 is actually the initial payment from the customer. So upon signing agreement, the customer will make 3 months installment upfront, which is the first, the one, and also the last 2 installment upfront. So along the payment term, the customer only pay from the second month until, okay, example is 36-month financing, they will pay up to 34th month only, because 35th and 36th, they have actually paid in advance, okay? So we have actually a normal set of a document that we actually required from this customer for the loan applications. So the normal is those company forms, the IC of the directors, the income tax or the audit account, and then the bank statement, which is 6 months, and the customer and also the supplier's agent report. So the documentation wise is quite flexible and is actually quite easy to get, okay? So finally, okay, if let's say you guys are interested to get any financing of a software for maybe software or equipment, okay, machinery financing, you can anytime contact me, myself, Nicole Chiang, or my colleague, Hao Junjie. You can text us or email us, also no problem. Okay, that's all my presentation. Thank you very much.
Thank you very much, Miss Chiang.
Yeah.
Wow, the the offer is very interesting, very much below than what we normally see for general financing, for business financing. Interesting. So the next round is actually question and answer. So I would like to see whether we have questions from the floor. I see Mr. Eddie raises his hand. So is there any question? Okay. So while waiting for questions from the floor, I have one question for Mr. Go, William. Okay. Since the product lifecycle management deals with a lot of documents and it goes from design up until manufacturing, right? So how does the PLM platform handles IPs? In the IPs, we have patents, we have especially trade secrets, things that documents that we don't want our competitors to have to be leaked out by the staff. So is there a way or a method whereby the organization can control all this information?
Well, so that is actually thank you for the question. So that is actually a part of the PLM processes. So what we are trying to in the PLM, so what we are trying to manage is actually a lot more on engineering related data. So in terms of IP and the design data are all managed under a platform, which is the I would say a PDM environment where it will where you can securely it comes with access, definitely it comes with access, like login access and security measurements. The data are stored either it's on premises or cloud. So the service providers will have already have a security assessment. But what we are talking about is on the IP or the design data proprietary. So that we manage those by workflow. So you can treat this way, meaning to say during a conceptual stage and so forth. So you can either control these data to be accessed by only a certain people, or it can only access by control different access to important data or non-important data. Now, if you're talking only on proprietary on engineering data, PLM will be a good platform for you to handle all these things. Now, if you are talking about informations or security measurements on things like quotation, quotations, SO, PO, and all these things. So that will be more like a task for ERP or a CRM. So that's why, like you mentioned earlier, 4 pillars. So these 4 pillars actually need to talk to each other well in order to achieve that. Now, what the industrials or what the organizations sometimes misunderstand is that they will go and implement an ERP and expect ERP to do what CRM can do, and expect implement a CRM and expect what CRM can do ERP and PLM related tasks, which is actually is a wrong, it's a not appropriate mindset. So PLM has its role. PLM's roles is mainly on engineering data. So things like properties, design, P&C, and so forth, that is handled in the PLM, which is the design data. So customer requests and so forth, yes, you can manage that in the PLM system as well. Let's say talking about quotation, pricing, and so forth, usually that is managed under a CRM or under a ERP system. So
those are under CRM.
Correct. So if you're talking about a direct way of handling this all IP and so forth, the answer is no. So the PLM only helps to manage the propriety of the data by controlling the access, making sure that the right data are accessible by the right persons only. So in terms of legal things and so forth, they are not built or meant to do all these kind of tasks.
Yeah. Okay. So yeah, I could imagine there's a lot of confidential information, data, design data, test data that are being shared and managed by the platform.
Yep, correct.
Okay.
That will be managed by control access and workflows. Right.
Okay. Another question that for Mr. Goh is just now you mentioned that the system can be integrated with cloud, right? So whereby machine data can be sent to the cloud and for data management, and then from there you can see whether on the operational side there's a surge in torque in your example, right? Will incur damages to the machine. My question is, do you support any cloud platform? Can it be private cloud, any servers, or
Yeah. Okay. So in general, if you are talking about storing data, I mean, there are 2 types of clouds that we are talking about in my presentation. So one type is purely for like a server for data storage, and then the platforms for the things into the clouds. So usually it will be a private cloud because public clouds will be things like Google Drive, the free login, or the OneDrive. Those are public clouds. So whatever data, design data involved, that will be private clouds. So private cloud platforms, Hitachi Sunways, we do have a private cloud called Excel Clouds with us, which is under Hitachi Sunways. Now, another cloud platforms that you see in my presentations, which is related to machine data and so forth. Now that is actually some sort like an IoT clouds, where it has the capability to process the data and give a feedback loop back to the machines to tell him to do improvement. So which is what we call as a closed loop productions. So that cloud collect data from the machines, like for example, and trying to learn what's going on. Like for example, whenever you do these operations, so usually there will be a jerk in the forces. Usually there will be a spike in the forces. So these clouds platforms will be able to analyze this data and eventually feedback machines to do improvement or to give a report to the users so that they knew that they will surface this problem that they need to solve in the future. So these are, I would put it as a two different cloud. One is a private cloud where it's only meant for storing data purposes, where you are just throwing the data in, you're just enjoying the surface, you are just enjoying the storage in the cloud and the easy accessibilities from anywhere around the globe, anywhere around the world. And there are another clouds which is a processing cloud or an IoT cloud kind of cloud where it has the capabilities to do big data collections, process the data, feedback loops to your productions or your fabrications floor so that a closed loop production improvement can be made. Where we always call like a preventive measurement, prescriptive measurements, and there's a preventive measurements, and eventually a prescriptive measurements where the cloud or the IoTs helps to solve all the problem on your own. But of course, that will be a very long journey.
Right.
Right.
Good. So normally when involve clouds, it will involve monthly subscriptions over time. So this is a question for Ms. Chiang. Just now you mentioned that the financing that you provide is more towards trucks, machines, whatnot. But PLM is, from my understanding, from when I saw what this William shared just now, is basically it's a software platform, right? So the first question is basically, does your financing or can your financing cater for various models, things like platform as a service type or hardware as a service, whereby the client or the buyer may not own the hardware itself, but it owns the result. So, this is one of the frequent software model that's being promoted by many industries now.
Hello, Mrs. Shazlan. Yeah, thanks for your question. Yep. So regarding just now, yeah, we are actually finance those equipment like trucks, machineries. But for software financing, we are actually a lot of software financing we have actually financed through the introduction from Hitachi Sunbase. So even ERP systems, yeah, CAD/CAM, we are actually financing. But just now, like what you say, if let's say those platform or hardware accessories, we are not financing because the end of the equipment, the result, it actually sell to third parties. So we cannot finance like those hardwares or the accessories.
Okay.
Yeah.
So those models, platform accessories, software accessories is not covered by.
Cannot. Yeah, accessories cannot. But unless if like software subscriptions, yeah, normally as I know, software you all have subscriptions, maybe 5-year subscription together with the software. Yeah, we do finance that.
Oh, good. That's actually my second question. So Mr. William mentioned, he mentioned that let's say I want to buy the PLM platform, and then I would like to get also the IoT cloud, right? So that means, let's say if I were to get the platform plus 3 years or 5 years of subscription costs for the IoT cloud, so you can actually finance the whole end to end.
Yes, we will try to finance the whole thing because as I know, this is a package that you're selling to your customer, and this is a special arrangement between the Mitsubishi HC Capital and also Hitachi Sunbase.
Okay.
Yeah, I believe not other finance, they will finance the subscription fees.
Okay. Does this model covers only with Hitachi Sunbase, or you also got the same thing for other vendors as well?
No, not under vendors. Yeah, it's only for Hitachi Sunbase, frankly speaking.
Okay, I'm just extending the possibility because I'm pretty sure the SMEs who are watching this webinar, may have questions, may have the need for financing, and then what you offer is very attractive. So whether we can go beyond what was being shared here.
Oh, go beyond. What do you mean? Like the tenor?
Yeah, I mean instead of just the solution from Hitachi Sunway, right? You can also cover financing for, let's say, if I were to buy from some other systems from other vendor.
Oh, okay. Okay. For example, if let's say the customer is buying one equipment from other vendors and then they also buying the software from Hitachi Sunway, of course I can give the financing for the customer. No issue on that. Yeah, no issue on that. Yeah.
Cool. Thank you very much.
All right.
Okay. Let me see what are the next questions. Maybe back to Mr. William, Mr. Go. What is your advice and what is your advice to those SMEs or manufacturers who like to get on board, with all this PLM technology? Because as you explained just now, PLM can actually cover from end to end, from design, manufacturing, testing, simulating the whole production floor. So let's say I have a factory, right, and I want to get what you're offering. So the obvious question, the normal question that came to my mind is, where do I start and how do I start?
Right.
Maybe Mr. William.
That's actually a very good question, very valid question. So maybe we want to go through by stages, or maybe we'll categorize things a little bit over here by first of all asking yourself, what is your roles in your organizations? So of course, if you are the MDs or you are the owners of the factories, then you got a lot of things to talk about. But maybe the attendees over here, maybe you are from production, maybe you are from design, maybe you are from the QC or anywhere. So first of all, let's look from different perspectives. So if I am the owner of the factory, so the first thing that I want definitely is that I want to improve the throughputs of my whole productions. So maybe through a PLM approach. So then the first question is that, do you have visibilities of all the departments, or how do you know the performance of each different departments or the products performance from start until the end? So at this current stage, do you have visibilities of whether the design teams are doing a very effective job, very productive job? Is the manufacturing teams are doing a very effective job? Is the QC team doing an effective job? Whether the production side are doing a very effective job or not? So if you have the visibility, then congratulations to you. You are already a very effective organizations. But if you don't have, then you need to start looking into how you are able to look at these different, or measure the productivity of these different departments. So in the design teams, so what kind of problems that usually you will hear? Like maybe design not on time, like something that I mentioned earlier. I always spend time in making sure the revisions is correct to the productions. I'm always searching around in PC1, PC2, in the server for the right files to use. I don't have a centralized standard parts for me to do designing. I always creating new parts. So always referring back to maybe ERP system or any part number, and then sometimes file missing, I need to rebuild the whole files again. So these are all the bottlenecks of a design house. All right. So because I am spending more time on those tedious jobs rather than focusing on my design. So as a designer, you should focus on your design. You are not supposed to spend your time in searching for files, spend your time doing all sort of non-productive tasks.
Yeah, that's normally what happens.
If you are able, if you are able to solve these problems or even improve by 5% or 10% of these particular problems, then there is an improvement. So you can get started from that perspective, right? So let's say in the productions, so if you're always talking about quality problems, you're talking about do not know that whether my machine or my production floor, even my assembly lines are running or not. So if you have a good visibility, immediately you will know how the root cause of the problem and know how to solve it. So the very first questions will be, do you even know that these machines are running? If there are two shifts, what is the performance of each shift? So is it the operators or the production manager just doing a good report for you to see, but then eventually your end part is still delayed. Your customers always say delayed, but when you look back at the reports, everything very done well, all the machines working 100% of the time. Now that definitely there is a problem. So either you don't have enough machines or the reports are not accurate. How can you, a simple question will be, do you even know by sitting here, listening to this webinar, opening a phone, opening a PC, or looking at a certain reports, you will be able to know the live data or the live production, whether machines are running, machines are not running or not. So if you are able to know that, then you will know how to do improvement. But if you do not have these capabilities of monitoring or understanding whether the machine are running or not running, so that's where you can start, at least getting to know on live if the productions are running or not. Then maybe the second stage is that how many parts they are producing per hours or even per day. 1 month can actually meet the customer requirements. So these are the small bits of things that you can do improvement as a start, because all these are part of PLMs, right? And of course, if I'm the business owner, then if the problem is with the communications between the design team, manufacturing teams, QC teams, or different departments, then you can look further into how we can move these decisions making or this data visibility across different departments. So these are things to solve. Now, of course, I'll do a deep dive into it. If today you are a design engineer, so again, ask yourself what are the tasks or what are the repetitive tasks that you are spending most time on, and how a PLM solutions are able to help you. I say PLM is a very big thing with different elements. So a small improvement is an improvement. So look into those small improvements. Do not be greedy. Don't look into the whole thing at one go. Look at the small things that you can do improvement, either with a software. Maybe it's just some simple communications among yourself, then that can be improved. Then eventually you will notice that you might require a platform to help to solve different problems. If you are a production engineer, you are a process engineer, then yes, look into the bottlenecks of what you encounter every day. So that is a small bits of things, a small bits of advice that I would like to give to the boss on here. So look into what you want to improve the most in your current daily jobs. So do you have a solution for it? If you don't have a solution, feel free to contact MEPN, feel free to contact Hitachi Sunway, feel free to contact us. We are able to give you some advice, how we should start on your digital journey, right? So in summaries, you have to know your bottlenecks. You need to know what are the things that causing you to have productivity losses. If you do not know, if you have no idea, then please do approach us. We are able to help you identify or help you realize these are the problems that you are facing, and there is a solution for it. And of course, the next stage will be whether you willing to invest or spend your time in adopting these solutions to make sure that you improve your productivities to be competitive in the market. Right.
Okay, thank you very much, William. So I like what you mentioned. One of your points you mentioned just now. Don't be greedy. So sometimes I think some of my past experience as well. People wanted to solve everything. So maybe they start small, right? Tackle one first, and then you start to grow.
Correct.
Another question that I have is basically some of the audiences may come from service industry, or maybe the vendor for a manufacturing company, right? So can you advise how can they use PLM to provide a better service for their client?
Um,
Or is it even related?
I would say yes and no. It depends on what you do. So let's say if you are only providing a services in terms of managing your service time, managing how fast you can address the problems, or maybe you are just supplying some products to the customer, etc. So that maybe can be solved by CRM or small ERP system where you're just managing
Right.
in and out data, managing whether the customer satisfaction, whether they are satisfied or not. But if your service involves producing a parts, doing OEM things for your customers, then yes, the PRM will come into the picture. Because like I say, it manage engineering data, design data, production data, etc. So if you are not managing all these things, you are just like a trading or you're just providing services, etc., then a more relevant solutions will be things like CRM or a small ERP system for SME to get started, digitalize your process of delivering your services to your customers. PLM might be something not relevant to you. The criteria here is that you have a set of engineering data, especially CAD data to manage, especially CAM data to manage, or if you are looking into simulating a CAE or CFD results for your customer, yes, then it's relevant. Or else, then not relevant.
Okay. So the key is for PLM is mainly for managing engineering data. So for all engineering consultants out there who provides services to their clients or for OEMs, for manufacturers, either you help them to design parts or parts of the machine. This is something that's very relevant to you. Am I right, Ms. William?
Yes, that's right. And especially when you are dealing with a lot of variants, always design changes and so forth, always need to managing the revisions of things. Yes, these PRM solutions PRM platforms or PDM platform will be able to assist you in reducing a lot of your non-productivity time.
Cool, cool.
Right.
So maybe I have one last question for Ms. Chiang. So just now, let's say I am an engineering consultant, and I would like to get, I don't have a factory of my own, but I provide services for my clients. So, that involves PLM and solutions from Hitachi Sunway. So does your financing cover companies like us?
Yeah, Shazlan, to answer your question, I believe this is quite a tough scenario to get the to get the financing for this kind of customer, because firstly, they don't have a fixed location of the working place. Yeah. And then the secondly is if they are only the consultants, okay. So yeah, is the customer having all kind of financial statements and those bank statement which is sufficient to submit for loan. So this is very subjective.
Okay.
Yeah.
So I think that is actually case, it's not outright no, nor neither outright yes, it's case to case basis.
True, yes, it's very subjective.
Okay. But at least there's some hope, for those engineers who would like to.
Yeah, it depends on what kind of document that customer can be provided, and the experience of the customer also help on the financing parts. Yeah. Experience, it means that how long is the company set up, how long the customer has been in this industry previously, where is the customer working at? Yeah, all this may help on the financing parts.
Okay. So one of the criteria that you're looking at is actually on the stability of the company.
Yes,
right?
yes.
And you mentioned just now the company may not have a physical
working place.
Working place?
Physical factory, they don't, because they are working as a consultant, I believe they might don't have any factory or office to run their business daily activities. So this might affect on the approval as well.
Okay. Means for consultants who have offices, maybe run, 3-4 engineers running CAD or design, that would increase their chances to be approved, to be considered at least.
True, correct.
Okay. So again, at least it's a hope.
Yeah. Based on, I mean, it also depends on how much is the amount finance. So if let's say the amount is not a really big amount, then we can consider. But normally we are more keen on those customer with a fixed factory, they have machines and they want to improve their production efficiency. That's why they come to this new software which is launched by your companies. Yeah, we are actually more keen on this kind of customers for financing. Yeah.
Okay, noted.
Yeah.
I think with regards to the amount, it very much depends. I mean, it goes back to what Mr. William said just now. Start small, so and then slowly grow. But then the headache that PLM solve, especially when it comes to engineering, design, and management, is real. There's a lot data and facts everywhere. Okay, thank you very much. I think it's already 4:20, and I don't see any more questions, and neither do I have any question. It brings us towards the end of the session. I would like to thank you very much to Mr. William Goh for your very eye-opening sharing, and Ms. Nicole Chiang for your very attractive financing option. Okay. So those who would like to have more information or would like to get further clarifications on the matters that was shared by our two speakers, you can either get back to MPC, or you can rewatch the webinar later on to get their emails and contact information. Okay. With that, before I end, can you see my screen right now? Okay, I should be able to. Okay, I would like to reiterate that under MPC, especially under the MEPN Machinery and Equipment Product Indexes, MPC provides business advisory clinics. The areas of consultations is on business development, operation, technology and digitalization, human resources, and whatnot, and so on and so forth, as what you can see in the screen. So those businesses who's eager to improve their productivity, who's willing to go to the next step, to grow bigger, start taking over the world, do contact MPC for assistance and consultation. Lastly, a note from our organizer, Mr. Rahman. So those who like to request for any e-certificates, okay, you can contact Mr. Rahman from MPC, and this is the email address. With that, I would like to end this webinar session, and I hope it is very beneficial, it's very meaningful to all the audiences here. Okay, I think we have covered topics and questions that may have come from manufacturers, factory owners, as well as contractors or vendors, right? As what the speakers mentioned, this topic is very relevant to all of us. As I think the concerns, the pain point that was pointed out is also is close to those who are involved with engineering designs, right? So with that, I thank you very much, and I would like to end the session with selamat petang and assalamualaikum warahmatullahi wabarakatuh. Thank you.